In fact, empty set also even without X implication, X belongs to empty set, first statement. Not to make more abstract, we'll assume that empty set also open by definition. Then the whole space for every X, the balls under at X radius are is contained in X. So we have defined open set. Then what is the topology mean? Collect all the open sets. That collection is having these two properties. Arbitrary union of members of that collection. We are proving that in
in topology we have done it. Yes.
Open, finite intersection of open set
is open. Yes.
That collection, just any matrix
Collection
space,
of neighborhoods, open sets. Yes.
the collection of open set will become a topology.
Yes. Sir, I heard that complex valued metric space having no topology.
Which one?
Complex valued metric space.
Complex valued metric space, first metric space for a given X non-empty set, you are telling D a map from X cross X to C. Then how you define D of XY less than or equal to order relation, all they have to introduce.
Yes.
See, on any set, partially order or some, they introduce some notion. Then no topology mean how to, suppose first if there is a topology mean, have a collection, that collection should have this property. See how first it without
open set you cannot.
No, open set we will define.
Okay.
No, like metric space. Metric space, no, what she is asking is complex
valued metric space.
Then what is the definition? Then, no.
For complex numbers, there is no ordering.
I mean metric, you mean D from X cross X to C.
Yes.
Then what do you mean by T of XY less than or equal to some other XZ plus the triangle inequality? Can we talk? Can we talk about triangle inequality? D of XY a complex number. One complex number less than or equal to other two, sum of two complex numbers. That's why then you introduce, there are some order relation. Not, that's what even if we introduce many of the new generalized metric spaces, first you have to check whether the collection, we are introducing some, whether call it S metric or some other metric, whether that collection, that metric will induce a topology.
Yes.
Then only we can talk about closed set. Yes. Then they define complete, whether every closed subset is complete.
Yes.
How? I mean, we are using some term. Whether, suppose we are given a sequence, where it converges to an element. What do you mean by convergence? You need a, in which sense? Even sometime without defining topology, they will tell that with respect to that metric what they call. But whether it is Hausdorff, whether with respect to that definition, a sequence, it may be possible to converge, suppose xn converges to x, xn converges to y, x not equal to y. Our iterative method say xn converges to x means that is fixed point. Xn converges to, same xn converges to y, suppose if the metric is not a Hausdorff metric. Then how do you know? Then x is also a fixed point, y also a fixed point according to that. Then how you will get unique? I mean, any new concept, actually some metric, some type of generalize, you want to generalize the notion of metric. First check whether it is inducer topology. Then what type of topology? Whether it is Hausdorff, whether, then Hausdorff means every sequence will converges to a unique point. First countable means we don't require to go to net. First countable, then x is in closure mean enough to say that x belongs to a closure if and only if there is a sequence xn in A which converges. If it is not first countable, then you have to say that x belongs to a closure if and only if there is a generalized sequence which is known as net. The net should converge, then all those things. First you have to analyze all the things, even a symbol. like similar to Banach contraction, but you are using there also closed, convergence, all the thing. But whether the convergence is unique, all those things we'll have to check. I don't know any.
Yes, yes, sir. Thank you so much, sir.
Any other? You want to clarify anything further?
No. I have
Sir, I have a one question doubt, sir.
I'll give you something to read about, to be clear about, for example, in a B-metric space, if you know what is this, there are at least 3 different topologies. We can define the normal the usual topology by the B-metric and then other 2 topologies, and you can understand what is the difference between them. So, yeah.
Sir, my question is going to Professor Barinde, sir. And what are the real life example of fixed point theorem?
What?
What are the real life example of fixed point theorem? The real life.
Real life
Yes.
example of fixed
Yes.
point?
Yes, sir.
Sir, how many of you went out for after lunch? How many of you came back and sitting in the same place?
This is. I wanted to give you the cup of coffee, you know.
Yes, sir.
If I do this, there is one point which remains at the same position. So they are moving around. So this is an example. This is an example of real life fixed point. But this is a difficult problem, is Brouwer fixed point theorem. There.
Yes, sir. Thank you, sir.
Think of real just for interesting, but understand the basic concept, why it comes. That's without knowing extent convergence is unique or not. You cannot just claim that the fixed point is one.
Yes, sir.
Sir, in the last class, sir talk about the game theory. Game theory is
That's the motivation we give. I mean, how in a natural way we get multivalued map. Then, using multivalued map, how we use for existence of Nash equilibrium point.
See, your hungerness means your diet. So every day you eat whatever you want, like iteration. Okay? So continuously you eat for 5 days or 6 days or 7 days. After the 7th day, the total volume of your diet is fixed. And whatever you eat within 7 days, that is only your diet. Divide, so average diet is the daily diet. Point is also the fixed point. That is also. Because after some time we also exhausted. So after how much work or after how much time you can spend on a particular kind of task. So when you are entertaining yourself, okay, your tiredness will be less and your entertainment is more. But when you use the brain work, and that too also not normal brain work, very heavy brain work, then you can understand that your tiredness is very fast. So you have to estimate this. So these are the problems beyond our, so now the computers are calculating such things.
Maybe about tomorrow we are going to discuss, already I mentioned, if it is a closed, bounded, convex subset of a Hilbert space, or even more generally, what is called uniformly convex Banach space, T from K to K non-expansive, then it has a fixed point, at least one. There, using Jones' lemma, will prove how we can prove how we are going to use it. Already we explained. Minimal invariant set, we told that invariant set is non-empty, contains exactly one element. And then the other, some other later. Any other?
It's a very, I think, stimulated session, entertaining session. Actually, normally I used to fix this every 4th day only. Because all the 3 days are hectic. And normally the GAN program is always hectic. Not only this GAN program. Last time also what we organized is that is also very, very hectic. First day definitely you have less patience. Because sitting on one chair continuously for 6 hours to 7 hours. So that is not an easy task. But I tried to make you more comfortable. Even your sitting is also very comfortable sitting, not the benches like that. So anyway, thank you. And I say that thanks to both professors and our colleagues, our office, all the participating teachers, participating research scholars, our own MSc students, and definitely they are fond of having this photographs with the learned mathematicians. That's good. These are the memories. Even today, I am having the letters. Those days we used to write the letters. I am having the letters of Billy Rhodes. I am having the letters of this Professor Baim Fisher. So all the letters are with me, and some of the letters are, mostly letters are motivating, because when we don't know each other physically, personally, but we know each other through the correspondence and some literature. So after some time we have some picture. That picture, it may not be exact the same picture, but we have the picture and we can gauge them.
In the correspondent itself, we can assume that.
Yeah, yes, yes. We are sharing the feelings also. Okay, so this time at least you do have the, what I say is good image also. But anyway, after the GAN also, we are planning for a virtual group. We are going to form over here. And many professors, they will join our group. Of course, these two are there. There are some half a dozen professors are there, experts are there, who are experts in their field. And we shall try that every Friday or every Saturday, we should organize at least one lecture virtually on that. That is what, on Zoom platform. And this will continue the whole year. This we shall try. So we are planning, I am planning in this manner. And we have some people behind that. And I shall see that that part is done from my end. Thank you. Thanks a lot. Tomorrow we shall start our session at 9:30 morning. Okay? Thank you very much. Please fill your feedback forms and submit the feedback forms by tomorrow morning.